All right, so section 7.4 is going down percents of interest. And as we work in this section, what we're actually going to be seeing used is a lot of proportions, okay, which is what we did back in chapter 6 at the very end of chapter 6. So to start with, let's take a look at what we actually mean by the word percent. The word percent comes from the Latin word meaning per hundred, as in our cent. Our cent is 1/100th of a dollar. And we actually understand that when we write down n percent, it means n over 100. Okay? It's per 100ths. So when we say something like our salary increased by 15%, it means 15 over 100. So for every $100 we made before, now we're going to make 15 more than we made before. There are a couple of different ways to talk about the percents. We can talk about changing our numbers into percents, or we can talk about changing percentages back into numbers. And there's a couple of ways to do that. So to do the numbers into percent, the two different methods, one of them is to simply take the number that you're referring to and write the number as a fraction with a denominator of 100. So in other words, if I were to write 7.9, I have to write there would be 100 down below. Okay, it's got to be a value over 100. And to do that, we would actually multiply, sort of if you think about it this way, this value is over 1. We would multiply the top and the bottom by 100. Okay? And if we can get the value to be written over 100, then the number on top is the percent of 100 that we have. So 7.9 is 790% of the number 100. So 790%. And then another way to think about it, and these are not the only two ways, but these are the two that your book brings up at this point, is to think about it as using a proportion. That is, if I write 7.9 over the number 1, kind of like we did here, instead of thinking about multiplying the top and the bottom by 100, we could actually do cross multiplication for that to happen. So if you cross multiply here, this actually ends up giving you n, because it's 1n, and this gives you 790, and that's the percent that you were looking for. So you can cross multiply. We're going to do a couple of examples before I switch the slide. Any questions so far? All right, so the first one is actually a number much like the 7.9. It's 42.6. And I'm going to do the first method for this one, not because I have to, just because I'm going to show you one of each of them. So I could actually take that 42.6 and think of it as being a number out of 1, or written over the number 1. And if I write this as a number over 100, what does that numerator become? Right, 4,260, which means that that's the percent. The 4,260 is the percentage of the number 100. That is a percent. So the equivalent of simply multiplying by the number 100, right? And we can do the same thing on part B. On part B, I want to do it with a proportion, partly because it's already set up in a ratio, which is kind of nice to use a proportion for it. So we're going to set this up in a proportion, 8 over 3 equals n over 100, and our goal is to figure out what in the world is n. Because if I can figure out what n is, then that will be the percent out of 100 that we're looking for. And so the proportion of 100. So we're going to cross multiply. So this is 3n equals 800. What do you find out that n equals? All right, so, and Kelly, you can write that in one of two ways. You can write it kind of like what you just said, 266.6 repeating, and I'm fine with that, but I just do want you to recognize that if you were looking at this in the back of the book, another way that it might be written is they might write that 266 and that 0.6 repeating might be written as 2/3, because 0.6 repeating is equal to 2/3. So you might see that variation of it.
Why would you write it like the top?
It would depend on what you were wanting to use it for. It might be more practical to have it written that way. Let's say you wanted to use that percent to actually perform a calculation. Calculations are often easier performed with a fractional value than a repeating decimal value, like in mathematical by hand calculations. So you might see it written that way. All right, we're going to go the other direction now. So now instead of changing a number into a percent, we're going to look at changing a percent into a number. And in practice, what this actually does is you write the number over 100. So whatever the number was to start with, in this case it's 4.5 or 4.5, so we can also recognize the same as this, right? Is that we write that number, the number itself, the 4.5 or the 4 1/2, out of 100. So we write it over 100. Now there's a couple things you could do. You could actually long divide this, right? It is written as a fraction with a divisor, and we could long divide this. But you also know from what we've talked about before that when you write a value on bottom as a power of 10, it's the equivalent of moving decimals around, right? So when I divide by 100, it's the equivalent of moving a decimal how many places? 2, and in which direction? Left. So if I take this value, and you can confirm with your calculator that you're seeing this happen, that this would actually be equivalent to the decimal point. You can put a 0 before it if you'd like. There will be a 0 here, and then 4, 5. So I actually had an experience very recently where percentages are notoriously miscommunicated. And I saw, and I will not tell you where I saw it because I don't want to embarrass the gentleman that actually did it. But I saw him write down, or I saw that he had written down that the tax rate was 0.85%. That's not the tax rate in Shawnee. Do you know what the tax rate in Shawnee is? It's 8.5%. It's 8.5%. So what he did is he actually wrote down the number he multiplies by to figure out the tax value. I mean, that's what he did. What he meant is he meant either 8.5% or 0.085 as a number, right? They're not the same thing if you put a percent on both of them. And so he had this sort of an issue going on with what he meant, that is the computation value that he was using, and he put a percent value on there to recognize that it is a percentage tax rate, but he mixed up the two notations. It's a pretty common mistake. Let's try this other one here. So if I take the 125, I do the same thing. I write it over 100. What would I end up with as the numerical value, or the number component value for this percentage? 1.25, right? So the original decimal would have been understood to be here, and I would move it 2 to the left. Because that's the equivalent of dividing by 100. Dividing by 10 and dividing by 100 are because of the bases that we work with. We're in base 10, and so when we divide by a power of 10, it is the equivalent of moving a decimal place. Yeah, and should we do that in 7.1 maybe? I can't remember. We talked about it in passing at least in 7.1 when we were talking about place value. Yeah. All right. So let me talk about where we're headed with this. There are 3 types of applications that percent problems can take on. And let me first clarify for you that you can do percent problems without proportions. 100% I agree with you. The nice thing about proportions is that they give a structure around which that you can solve all kinds of problems like these. They provide structure. And that's a really nice feature. Because otherwise what you are left with is sort of changing language into math symbols, and students really struggle with that. Perhaps some of you guys did too, I don't know. But the nice thing about proportions and solving these is that they actually they actually give you structure to solve the problems. So let me show you the 3 different kinds of examples of the types of applications you can see with percentages. So the first one is finding a percent of a number. So for example, you might see a question asking you some form of what is 15% of 32? Oops, it's supposed to be a question mark at the end. Where you're taking a value and you're asked to find a percentage of it. Where do you see this kind of application used for real life, real stuff?
Shopping.
You do that with shopping when you talk about percentages off of things. Where else? Tips. Yep. So if you're figuring, it may not be 15, but you figure this with tips potentially. I contend that you also, whether you're cognizantly aware of it or not, figure this with your tithe at church. Right? You're finding a percentage of what you make to give in an offering plate. So this is one of the applications. The next one would be finding what percent one number is of another number. So something like this where you're asked, what percent of 47 is 12? Where do you see this kind of thing used?
Science.
See it used in science. Do you have a think? Are you thinking of specific
Well, we
examples?
just did a lab, so
You just
we
did a
had
lab
to
where
figure out what percent of a certain amount of cells we saw splitting, and then figure out the time.
yeah, you do use it in science, and you also use it with things that either grow or decay in science, right? So if you're talking about sort of looking at a petri dish or something like this, where something's multiplying quickly, or where something's dying off, you can talk about how much is left of what you started with. Definitely used there. Any other thoughts you guys have?
What about in cooking, if you need to have the recipe?
You could do it with cooking. You guys are missing one that's really common. Like you use it all the time, and you're going to use it for the rest of your life. Somebody say it.
Grading homework?
You're really close to it. Yeah, that's the idea of it. It's your grades. This is what your grades do, isn't it? You figure out how many points you have and how many points were available, and you figure out the percentage that you get on a test or a quiz or a homework or your final grade in the class. Yeah, so this is one that you use a lot, and you guys are going to get to continue to use it a lot. Here's another one, though. So this is finding a number when a percent of that number is known. So 13 is 45% of what number? Any thoughts on that one? That's how we're going to solve it, you're right. But I want to think about if there's an application you can think where a problem would be set up that way. So you're ahead of me, because that's where we're headed next, Kelly. You're okay. I actually think that you use this one in shopping sometimes too. You use actually all three of them you could use in that way. But this one you often will see used in shopping where you'll see the new price of a product and they'll tell you that the discount was some kind of percentage or whatever, hey, this was 35% off or whatever. And if you wanted to, and if you spent a significant amount of money, if there's anybody else you're responsible to for that money, you might actually have to sort of outline with it. But it was a really good deal because the original price was, right, and Kohl's does this all the time, right? You never play full price. Yeah, so this is actually used, another example of this would be used for, could be used an example of in shopping. All right, I'm going to do an example of each one of these. Let's take a look. So here's our first one. All right, so this one says, what is the sale price of a softball if the regular price is $6.80 and there's a 25% discount? Before we get too far into this one, the first thing you have to realize is that it's asking for the sale price, but it's telling you the discounted amount, not how much you're paying of that. So first of all, be aware that if there's a 25% discount, then the percent you pay is what? Is 75%. So you need to make sure that you're careful about what information is given and that you're structuring it in the proper way. So when you're working with proportions and percents, the beauty of what's going on is what Kelly had mentioned earlier, is that you're always going to have one of the sides of the proportion out of 100, and the percentage is always going to go on top. So if you're given the percent, that's the number that's going to go on top of the 100. So half the equation's already set for you. You don't have to do anything. The other side is going to be, in this case, whatever these values represent. So the 100 would represent the 100% of the price of the product. That's the $6.80 because that's the regular price. And the sale price is the 75% price that we actually don't know and we're looking for. So I'll call that X for now. it provides a structure that you can simply put the values into the place where they logically go. That's the nice thing about proportions. And then you guys already know how to solve them because we've already talked through this back in chapter 6. So what would we do? Cross multiply. So this gives me 100x on the left, or the right, however you multiply. And then the other one, what is the 75 times 680?
510.
And then what would we do? Divide by 100. $5.10. And we do want to make sure that we have the corresponding, in this case, dollars and the units on there to make sense of what's going on. Now pause for a moment and think with me. Sorry, give me 1 second. Let's say that you forgot to do the 75% and you did it as 25. And you put the 25 right here instead of 75. You're going to get a different answer. But what is that answer going to be telling you? How much of the discount you got, right, in dollars. So if you had done that and you get to the end and you go, it doesn't sound quite right, and you don't want to actually rework the whole problem as is, what could you do to find it? You could subtract it from the 680. So you could actually work your way out of that by thinking about it in a different light in that case too. Yes?
Would
Question?
you, instead of doing like 7,000 proportion, would you be able to do 6.80 times 0.25 and be able to get $5.10?
Yes, there are other ways to do these problems. Their book is wanting you to put them in proportion form. Again, because you're seeing that, because you've got some previous exposure and thought through how to work with percentages. Again, the nice way of dealing with, the reason that we're dealing with the proportions is because they've got this nice structure set up for us to start with.
Okay.
Yeah. Yes, there are definitely other ways to do the problem without a doubt. Okay, last question on this slide says, what type of a problem is this? There were 3 types of problems you guys have on the slide before. Percent of a number, percent one number is of another, finding a number when 1% of a number is known. So what is this problem? Which number? 1, 2, or 3? It's number 1. We want to find out what is 15% of 32. We are finding out what is 75% of 680. This is problem number 1. This is an example of problem number 1. All right. Here's another one. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? So let's actually answer the question at the bottom first, just because it'll help us maybe process a little bit of what's going on. Which type of a problem is this? Number 2. Number 2, finding what percent one number is of another number. It's number 2 because we aren't given a percentage, right? We're actually looking for that. So this is a problem number 2 variety. Now I want you to also pause and think, this has a variation to it that was much like the last problem. The question that we're actually asked to find is the percent of increase. Right? How much did his house increase in value? Okay, so Kenzie, how are you getting that value? Right. So we're subtracting our new value of our house, which happens to be our larger one in this case, minus the original value of the house. That's the increase in value of the house, which is what we're asked about, right? So as we take a look at this, again, the problem always sets up as being over 100. And in this case, we know the part we don't know. We don't know the percent, which is the value over here over the 100. That's what we're looking for. So we have to figure out what goes in the other 2 locations then, right? What do you think? What's going to go where? Well, 100%, the 100 is the original value.
So then the 159,000 on the bottom and 36,000 on top.
And then the percent increase, which is what we're looking for, like Hannah said, what will go on top, that was at 36?
Yeah.
36%. 36,000. Do you understand the setup? The original value is always what's on bottom, right? Think about the last problem. The original price was the 680. The original price or value of the home in this case was 159,000. And then we're going to cross multiply just like on the last problem. So I have 159,000 times x equals, and if I multiply this by 100, do you know what you get? $3 million, there we go. 600,000, you got it. 3,600,000 is good. And so then our last step that you're going to use your calculator for is to divide by the 159,000. And the answer you get, the units on it are going to be what? Percent, right? Because this is not a dollar amount, we actually are finding a percentage this time. So what do you get for x?
22.
Yeah, I think you're off by one of your zeros.
22.6.
Okay, so let's go with one decimal place. They do say approximate. So 22.6%, or if you want to say 23%, that would be okay. So we're looking at about a 23% increase. So let me talk through a couple of things with you on how the problem could have been done a little bit differently and still arrive at the same answer. If you had gotten it set up the same way that we did, one of the things you could do to simplify the problem before you do the multiplication is you could recognize that these three zeros are matching, and your numbers would be a lot smaller to deal with, right? In essence, you're dividing both of them by 1,000. You could do that, and your answer would end up the same, okay? The other thing is, let's say, for instance, that you did not recognize or didn't think about having the 36,000 on top. And instead of putting the 36,000 on top, you put the new price of the house on top. Okay, so you put the 195,000 on top. Any idea what you would end up getting down here for x equals at the bottom? Do you know, Hannah?
Should get like 86%.
It's a good guess. Nope. Guys, can we talk? Yes, that's right. You would end up getting 122.6%. You'd get 100% more because that's the 100% of the house price that we removed when we subtracted the 159 from the 195. So if you had gotten to the end here and you had done it the other way, you would have gotten 122 because you would have had the original 100% of the price of the house plus the 23% or 22.6% increase. So you can still, again, get the right answer, right? You would just have to recognize what that 123% means. It means that the price of the house is 123% of what it used to be. The increase then was the 23%, right? Because it was originally worth 100%. Okay, we've got one more example about ski slopes. It's almost spring break, right? Does anyone want to ski in? Nobody? You are, yeah, I wish I were. All right, this is a ski area. They report that 80% of the runs are open, and there are 60 runs open. And so our question then is, how many runs do they actually have at the ski slope? Or we could equivalently be asked how many runs are closed. We could be asked that question as well. This one's asking how many runs they have total. So what type of a problem is this? This one better be number 3, because I told you I had one of each of them, right? It is number 3. Let's take a look at why before we get too far into it. Number 3 would be finding a number when a percent of the number is known, right? So we actually have a percentage of the number that we're looking for. We have 80%, and we know that 80% of that number is 60. All right, so we are going to set this up just like we did before. It's a percent, so it's over 100. Somebody tell me where something goes.
100 goes on the bottom.
100 goes on the bottom after that. 80 goes on the top, doesn't it? Yeah, because the percent's all go on one side. Okay, so that's the part that you usually can just put in without the explanation. I have to be a little more careful. Where does the 60 go? It goes to the top. Why does the 60 go on the top, Hannah? Yeah, that's actually, that 60 is equivalent to the 80%, right? That's actually representing what is open. 80% are open, that's 60 runs. So the part that we don't know in this problem is actually the full number of runs, or x is on the bottom. Alright, so we're gonna cross multiply, right? Alright, 80x on the left. It's 100 times 60. 6,000. We divide by 80, what do we get? 75. 75 what? Let's see, runs. These aren't the ones that are open, these are runs total. This is the total number of runs at the entire ski slope. 60 of them are open, 75. So how many are closed? 15 are closed, that's right. Alright, change of directions, you ready? Oh, you guys, man, I tell you what. We're gonna do a little bit of mental math. Mental math is interesting. So one of the caveats to mental math is that I can't see inside your head. Did you know that? I know. I wish I could see inside my children's head. That well, maybe it might be scary. I don't know. But yeah, I can't see in your head. So when it says something about mental math on this, I recognize that the whole point of the mental math is for you to be able to do something in your head. But I would like for you, especially when you get to a test, I'm definitely going to ask you to explain your reasoning. So it would be a good idea if on your homework you write down a couple of thoughts as to what's going on inside your head to justify what in the world you wrote down as your answer. Does that make sense? Okay. So a few things about mental math that are good to keep in mind, that's what this slide's about, is fractions that correspond to certain percentages. So if we have 25%, what fraction corresponds to 25%? That is 1/4. Very good. What is the fraction that corresponds to 50%? 1/2. About 75%. That is 3/4. All right, so here's that weird percentage, Beth, that we were talking about before. Actually, this is the second one, but right, 33 and 1/3%. What is 33 and 1/3% as a fraction? That's actually 1/3, right? Because that's 1/3 of the number 100%. What is 66 and 2/3% as a fraction? That is 2/3. What is 10% as a fraction? 1/10. And what is 1% as a fraction? 1/100th. Very good. We're going to use this in the next slide, okay? Or at least use parts of this. This question says to solve using mental math, which means the intent is not for you to set up proportions like we did in the last section. Right? Those last 3 questions we did were proportions in grade, and we could use them here, and that'd be fantastic. But right now, what we're asked to do is to do this using mental math. It does not say approximate, so you're not allowed to try to change numbers into more convenient or happy numbers to use. You can't do that. But you're supposed to use the approximation methods that you know, not approximation, but the mental math simplification things that you do in order to do the problem. So let's take a look. We're trying to find 15% of 42. How might you do this? And there's more than one way to do this, but I will contend that not all of them involve just mentally doing it. You're not supposed to actually sit down and multiply something out. You're supposed to be able to compute part of this or all of this in your head. So what would you do? Any thoughts?
Maybe 10%.
So could we find 10% and 5%? Yeah. And if we found the 10% and the 5%, what would we do with those numbers? We would add them together. So 10% is easy to find of a number because what does it involve? Simply moving the decimal. So if I took 42, what is 10% of 42? 420, right? I'm writing it in sort of in the form for money. How can I use that information then to find what 5% of it is? Half it. So the half of this is the 5% of 42, which is what? 210. And what's 420 plus 210? 630. $6.30. Okay. So if you had 15% off sale and the sweater was $42 originally, you'd be saving $6.30. Make sense? Okay. And this is the kind of work that you don't do in your head, but your head thinks it, right? So if I were you, I would jot down a few of those things, because on a test, that's the kind of reasoning that you have to be able to justify. Try the next one. What about 20%? What could you do? Yeah, one way to do it would be to look at 10% and add another 10% to it, right? So what is 10%? Or you could do 10% and then just double it in essence, right? So what is 10% of 280? It's what? 28. And if you double it, or add it to itself, what do you get? 56. Okay, so those awesome pair of shoes that cost $280. 20% off, which means you save 56 bucks. Okay? How about 5%? Right, so we would do 10% and we would half it. Much like we already did in the problem before up here, right, with the 5% there. Okay, so we have $28, so what's 10%? So 10% of 28 is actually what? 280. And half that is what? 140. $5% off is not going to get you by pretty much anything. So, the last one is 25%. And, well, let me just ask you, how could you do this problem? Divide by 4 is the easiest way to do it. Did anybody else think of a different one? You could do the 10 and the 10 and the 5, which works too. So there's two distinctly different ways to do it. The 10 and the 10 and the 5 looks a lot like the parts we already did, right? So I'm going to show you the other one just because we haven't done one of that variety. So 25% of 84 could be done as recognizing that 25% is equivalent to the fraction 1/4. That doesn't look like 1/4. That's better. So it looks it's 1/4. So we could actually talk about taking the number 1/4 and multiplying by 84. That's actually really nice with this particular one because 84 is nicely divisible by 4 to give me what? 21.
If the number wasn't like, if you couldn't just tell by looking at it what it was, couldn't you just take half of it and then divide that by 2?
Yes. Yeah, you could. So Hannah's suggestion is couldn't we just sort of in essence divide by 2 twice, right? Yes, you could. Especially if the number weren't so clean and pretty as 84 is. You could just take half of it twice. Okay, I already sort of addressed this issue in the example that I saw happen in real life recently. Is 0.4 equal to 0.4%? So you know the answer is no. That percent actually means something has happened differently to the second value. So we can talk about either of these numbers and talk about what they actually mean. So if I were taking this number, we'll go this direction, and turning it into a percent, what would I actually do to turn this number into something that's a percent? I knew the decimal twice over because I was actually doing what? Multiplying it by 100. You're close. Yeah, multiplying it by 100. So this is what we were doing on the very, very first of the lesson, where we said we can write this number as something over 100. And that's in essence the same thing as moving that decimal over like you guys just said. So this is actually 40%. So 0.4 as a number is actually the same as 40% as a percentage. So it's not the same, right? That percent at the end means something different. Take a look at example 8. This is a true statement. It is possible to have an increase in price of 150%, but not a decrease in price of 150%. Why? What do each of those mean? Okay, so Becky, you're addressing the second one, the decreasing part, right? Can you say that? So can you say that a little bit louder for me?
Like increasing more than the value, so you can't like subtract.
Right, so if we found 150% of a value, it'd be more than the value we started with, right? So if we took that original value and we subtracted it off, like you're suggesting, we'd actually end up with a number that would be negative. And most stores are not going to pay you to take their product. If you want to learn about coupon shopping, sometimes they will pay you to take their product. But it's not advertised in that way, at the very least, right? It's not advertised that way. So, so if you talked about an item, and let's just use the easy number of 100. Let's say that the product is actually cost $100. So if you talk about a product that costs $100, 150% of 100 is actually 150, right? So we can't decrease the $100 item's price by $150 because then we actually end up with negative value. Can we increase it by $150? Sure. All you have to do is to take that original product that was $100 and add 150 to it, right? The issue is that you can always increase a price more than the price actually costs, but you can only decrease the price, the total amount of the price, which is 100%, and then they're giving it to you for free. Okay, so let's write a few things down on this. We can only decrease a product the value the product has. Say it that way. Which is 100%. But we can always charge more for a product. $150%, we could do 200% increase, and it can go up from there. Okay, it doesn't matter what the value is. We can always increase the price of the product that we're selling. Nobody may buy it, but we can always change the price to increase it higher. We can only decrease it the amount of the product itself. There's one more topic in this chapter to take a look at, and it's the topic of interest. Okay, so the chapter section actually was titled Percent and Interest. So this is the interest part of the section. Interest is the amount of money you pay or earn to borrow or lend money. Okay, so you can either be earning interest on your money that's sitting in the bank, right, or whatever, or you can be paying interest on things that you owe money for, like loans. Those are the two ways, but they're both called interest. You either get it or you pay it. Principal is the original amount that you use to determine your interest. So it's either the original amount you put into the checking account or the savings account or whatever and don't touch, or it's the amount that you borrow for the cost of your education, the car, the house. That's the same thing, okay? It's the amount that you're using to pay the interest on. There's two types of interest. I'm sorry, I skipped one. The interest rate. The interest rate is the percent that's used to determine the interest. So you see this advertised all the time with car dealerships, right? 0.9% APR financing for 60 months, right? That's the percent they're using to determine that. You see them used that way for housing prices. You see those on TV now too. When they talk about the percent for your house, percentages have dropped and you need to refinance your house tomorrow or yesterday or something like that, let's say. Or you'll hear it talked about when you put your money into a CD or a money market or a savings account. You have the highest percentage return on your investment when you put your money in our bank. And they'll talk about a percent there. There are two ways to do interest. One is simple interest, the other is compound interest. Simple interest is typically what people do when they do a, like between two people kind of a lending. So if your parents loaned you money, they probably use simple interest to calculate the interest. It's easier to work with, it's more manageable, those sorts of things. Compound interest is what the bank or the car manufacturer, whoever it is you're borrowing money from, or that you are putting money into a financial institution, they use compound interest. The difference is the way that the formulas work and how they compute what's going on. So typically simple interest is charged in advance of you paying anything off. So when you owe money, you really wouldn't want them to use simple interest because it means that no matter if you pay a loan off early or on time, you pay the same amount of interest either way. That's simple interest. Compound interest actually means you only owe interest on the amount you still owe. And that's a big deal. So if you've paid off some of it, you don't want to pay interest on the part you already paid. You only really wanna pay interest on what you still owe money on. It's the way your credit cards and things work too, when you pay interest on the credit cards. You only owe the interest on what you still owe. Alright, so we're gonna do some examples of how this actually works. Trying to decide what I wanna do. Okay, I wanna pause this today.